So those who don't know me, I'm Patrick, and I'm also an ME patient. I've had the illness for 6 years now, almost 6 years. But I'm really excited to give today's talk because it's really about it's German research from top university, which is really trying to explain what ME/CFS is like in total, like a big picture of ME/CFS. And for me, this model makes a lot of sense. And when I first came across it, which was a couple of years ago, and understood it, I actually felt like it demystified ME/CFS, and I didn't really feel like what I was suffering with was so hard to understand. And I really hope it has a similar effect for you as well when I explain this research. So, title of the talk, ME/CFS, what is it? New German research on ME/CFS as an illness of global hypoperfusion. I'll explain that in a moment. This research comes from two academics. The first is Professor Carmen Scheibenbogen, who leads the research center and clinic at the Charite University in Berlin, which is one of the leading German universities. And the second researcher is Professor Klaus Wirth, who actually doesn't work at Charite. He's actually an expert in drug development. So he had a decades-long career at Sanofi. And these two have collaborated, writing about 5 or 6 papers over the last few years, really trying to work out what is ME/CFS, like if you take it in the round. And their research has been very well received. So in short, you could say that ME/CFS is this term, global hypoperfusion. And what that means is that globally, throughout the whole body, there is a state of blood hypoperfusion. That is, a hypo means reduction. So there's a reduction of blood perfusion throughout the body. That means that there is less blood seeping into all the different aspects of the body, pretty much, into the muscles, into the brain, and various organs. And so immediately, just in a very basic way, this can explain an illness which has exercise intolerance as its main feature. Because if your muscles do not perfuse with blood properly, and you try and exercise, they'll give up really quickly. So it makes sense at that level. Now, in the talk, we're going to be looking at 3 main things. The first is the 4 main reasons why this global hypoperfusion comes about. They are vascular dysregulation, low blood volume, and more briefly, we're going to talk about microclotting and something called heart preload dysfunction. Then in the second part of the talk, we're going to look at cellular dysfunction. And in the third part of the talk, we're going to talk about what does all this suggest for treatments, whether now or in the future, in an ideal world, which of course we don't live in. So that's the plan. Before proceeding, just a few little things to say. On the screen at the moment, you will see a diagram taken from one of Professor Wirth's latest papers in which she's summarising these mechanisms. And I wanted to show it to you to give you a sense of just how complex this research is. There's a lot of stuff here. I wouldn't have the level of understanding to be able to explain it at this level. But I just wanted to give you a sense that this is like very complex. What we're talking about today is much more simplified. Today's talk is likely about the central mechanisms in ME. There are plenty of other things I'm not mentioning today, which are probably happening downstream of what I'm describing. And there are, of course, also other theories about ME/CFS and models, but I don't necessarily think they're mutually exclusive. They can coexist. And finally, it's important to mention that all of the mechanisms I'm talking about today get worse when you crash. They're worse during post-exertional malaise. Okay. So the first reason for the global hypoperfusion, vascular dysregulation. So there's a specific problem in the blood vessels in ME/CFS. It doesn't happen in all the blood vessels. It happens in a kind of blood vessel called the resistance blood vessel. These are the vessels that are in the muscles and brain. They're also in various organs. It's not referring to the blood vessels that are giving blood flow back up to the heart. They're called the capacitance blood vessels. That's a different situation, so it doesn't apply to them. And what's going on with these blood vessels in the muscles is a vasodilation impairment. Now, vasodilation means to open up the blood vessels. And if that's impaired, it means the blood vessels are not able to open properly. So they're actually staying a bit too tight. And what this means, if we just think about the muscles, is that they're not able to receive adequate blood, because they would normally need to open to actually let the blood flow into the muscles when in lots of different situations, but particularly when you're exercising. So a healthy person, when they want to go for a run, I can't remember exactly, but it's either that the blood flow into the muscles has to increase like 40 times compared to at rest, or 100 times, but it's a huge increase. And if that's not able to happen, the muscles are going to say, nope, sorry, no can do. So they'll give up. So this immediately kind of explains why someone might have difficulty exercising. But why is it actually happening? So there are two reasons. The first is the autonomic dysregulation, or dysautonomia. So I think we're all quite familiar with this and with this feeling. So this is when the nervous system is going into this excessive flight or fight state, sympathetic state, and it's pumping out lots of stress chemicals. These stress chemicals reach the blood vessels and actually instruct them to stay too tight and not to open, because stress tightens things up. So that's one of the reasons. They also, over time, lead to something called vasodilation receptor desensitization. So all these waves of stress chemicals hitting the blood vessels desensitize the receptors, which normally control the opening of blood vessels, and they become sort of blunted to this. So they stop doing it. Is this noise okay? Can someone give me a thumbs up, because it's...
Yeah, it's fine. You're grand. We can hear you clearly. You're coming across good.
Okay, great, because it's certainly loud to me, but if it's ever bad, I can go outside.
Okay.
So that's the first reason for the blood vessels not opening. The second, very important, is autoimmunity. So ME/CFS is actually associated with a specific autoimmune problems, about 5. And it's a huge topic. It's responsible for a lot of symptoms. I'd love to give a talk on it some other time. But one of these autoimmune problems, it's a little kind of autoimmune substance. It's called an autoantibody. And it goes and actually lives in the blood vessels, and it stops them from opening. It instructs them not to open. So if someone has this particular autoimmune problem, it will also be a contributing reason for the blood vessels staying too tight and not allowing the perfusion into the muscles, and indeed into the brain. We think of brain fog, cognitive issues, why you feel sometimes a bit like you've got early onset Alzheimer's or something. I certainly feel that way sometimes. The blood flow is not getting into the brain. Okay, so those are the two main reasons for the vasodilation impairment. We're now moving on to the second big reason for the general state of the low blood perfusion. That is the low blood volume. So this is what I talked about last time. ME/CFS patients often do not have enough blood, in case you didn't know that. And depending on severity, like the more severely ill you are, as a rule of thumb, you will have less blood. So one research paper actually found that housebound ME/CFS patients are slightly over a litre short of blood in comparison to the norm. Now, one thing we didn't really talk about last time was, why is this actually happening? We touched upon the fact that ME/CFS patients, their bodies are losing more salt than a healthy person. And we talked about a bit why that was happening, but we didn't go into like, why does it happen at all? Because it's very strange not to have enough blood. Like, it's really odd. And actually, this German research I'm summarising today can explain how the low blood volume comes about. And it actually comes about because of what we just described, the vasodilation impairment. So the one thing leads to the other. And so in this section, I'm going to describe to you how that happens. It's the most complex section of the talk, so hang on in there. So basically, what happens is the brain senses this problem that the blood isn't getting in everywhere in the body, and it doesn't like it at all. It's really stressed by it, and it wants to change it. But it also recognizes that the normal ways of doing this are not available. So it needs to find some other way to force the blood vessels back open. Now, ultimately, what we're going to see in this section is the brain's attempt to correct this problem is going to fail, and it will end up creating the low blood volume as a side effect for two reasons that we will explore. Those two reasons are the salt loss, because the salt retention mechanisms in the body are going to be suppressed. And secondly, there will be a loss of blood from the active circulation. It's actually going to seep out of the blood vessels because of little tears or little micro leaks that will occur in the blood vessels. This is something we didn't talk about last time, but I'm going to describe it to you today. Okay, so how on earth does all this happen? Well, let me introduce you to a system that I've never heard of, and I doubt many people have. It's called the Kallikrein-Kinin system. It's a system in the body. And it is a system that is capable of creating vasodilating chemical messengers, vasodilating substances. Some of the names of these substances are bradykinin, prostaglandins, adenosine, and others. There's about 5 of them. So you could say it has various functions in the body, but you could say this is a vasodilation creation system. So in the context of a situation where the body's not able to vasodilate normally, the brain naturally turns its attention to this particular system and says to it, look, mate, can you please ramp up your activity, create a lot of vasodilators for me, shoot them out to the blood vessels, force them open, and restore the perfusion. So that's what it's thinking. Let's use its backup plan, basically. Now, ultimately, it doesn't really work. It will open the blood vessels a bit. So it's not entire failure. But ultimately, the autonomic and autoimmune reasons that are keeping the blood vessels too tight in the first place, that's just too strong. So it's not possible to overcome that. So it doesn't really work. But it comes with 2 devastating side effects. First one. So the body, many of the systems in the body act in balance with each other. So if one system gets its activity pushed up, another system might get its activity pushed down, because so many systems are listening to each other, and the body has just certain physiological laws. One thing gets upregulated, another gets down. So what happens if this system I've just described, the Kallikrein-Kinin system, what happens if that gets increased in its activity? Well, as a natural physiological law, it acts in opposition to the system in the body that controls salt, holding on to salt. And that is the renin angiotensin aldosterone system. It's a hormonal network whose job is to sense how much salt you have. If it's going low, it increases its activity to hold onto the salt. If your blood volume is going low, you vomit, for example, or you're sweating a lot, you lose blood volume, this system will push up its activity to hold on to the salt. But in ME/CFS, it's been noted for years in research that this system to hold on to salt, its activity is strangely low. And it shouldn't be, right? It shouldn't be. So for a long time, researchers have said, okay, this is the reason why there's the salt loss in ME and the low blood volume develops, but they have never been able to actually explain why this salt retention system is becoming suppressed. Like, that's always just been a mystery until this research. So the reason why the salt retention mechanisms go down is because this kallikrein-kinin system creating the vasodilators, activity is going up. And as it goes up, it suppresses the salt retention automatically. It's a physiological law. It just happens that way. So I just wanted to put this in a kind of picture just to convey the point. Here's weighing scales. On the one hand, you have the kallikrein-kinin system producing the vasodilators. And on the other, you have the renin-angiotensin-aldosterone system holding on to salt. As one goes up, the other goes down. And that's the reason why in ME/CFS, patients are losing salt all the time in their urine. And I'm sure you've noticed you crave salt. This is what all ME/CFS patients pretty much say. They crave salt because they can't hold on to it. So yeah, every time you go to the toilet, you're peeing out more salt than a healthy person. This will be worse in post-exertional malaise. Over time, this salt loss will lead to a state of low blood volume. And once the low blood volume actually becomes developed, the body can't correct it for the exact same reason. Healthy person, low blood volume, not catastrophic blood loss, a little bit, body can correct it. Can't happen in ME. So you get low, stays low. So that is the first main reason for the development of the low blood volume. The second main reason, vascular microleaks. So this is a kind of, it's caused by the same problem, but the upregulation of the kallikrein-kinin system, but it's quite different. So the other thing is that when the kallikrein-kinin system creates all these chemical messengers, these vasodilators to actually shoot out and try and open up the blood vessels, these chemical messengers are actually very powerful. And they're actually, when they reach the blood vessels, they're actually capable of damaging them a little bit. So they reach them and they can damage them and cause a little leak, a micro leak. And that means that you start to lose a bit of blood from the active circulation. It actually goes out through this leak. So it's still in your body, but it's no longer in the active circulation. It goes into something called the interstitial space, where it is of no use to your body from a normal blood point of view. So it's actually staying in your body, but seeping out of the active circulation. So with these two reasons, the low blood volume develops. And what you can see from this is just how much of an illness of vicious cycles ME/CFS is. You know, the vasodilation impairment is like bad enough. You know, that's already causing a reduction in blood perfusion everywhere. But then when you actually get to the point where you have the low blood volume and you don't even have enough blood in the first place, well, this lack of blood perfusion, lack of blood seeping in is even worse because your body's got less to work with. So the exercise intolerance becomes worse, the anaerobic threshold becomes lower, and the recovery from post-exertional malaise becomes worse. Everything gets worse. It's a vicious cycle. That's a theme. It all gets worse. Anyway, so those are the first two reasons why the hypoperfusion comes about. The next two, touching on very briefly, just a slide each. So something called microclotting, which I talked about last year. And this is a phenomenon where the blood in ME/CFS is filled with these tiny clots. They're absolutely microscopic, but there are many of them. And they are created by the core dysautonomia pathways, which drive naturally an upregulation of clotting pathways. And the general inflammatory state of the body creates these little clots. And so they're a unique problem in ME/CFS and POTS, long COVID, these kinds of illnesses. They fill up the blood, they make it very sluggish, very thick. They actually darken its color by condensing it. You might have dark purple blood, black blood. And they interfere with the transfer of oxygen from the bloodstream into the muscles. So this is like another major reason for the exercise intolerance and the general lack of blood getting in to everywhere. People who are interested in more on that, please see my talk from last year, which is also on the YouTube channel. The final reason for the hypoperfusion is something called heart preload failure, not to be confused with heart failure. This is a unique ME/CFS cardiac problem, first identified by Harvard. And what it refers to, it's the moment of the heart loading up with blood. So it relaxes and it loads up with blood and then it pumps it out. And so it's referring to a problem with the actual loading of the heart with blood. There's an inadequate blood return to the heart during that moment. And so it's a kind of preload failure. Now, this is happening because of everything we've just described, basically. Obvious example, if you don't have enough blood in the body in the first place, you're obviously not going to fill your heart up with enough blood to pump out. But it increases the hypoperfusion because the heart, like to normally perfuse the tissues, good, strong heartbeat, lots of nice blood being pumped out to reach the tissues is needed. If the heart's not able to do that, it's pumping out less blood to the tissues, the perfusion is also going down. And so you get this, what's called a low cardiac output state. Now, very important, I have in capital letters here. In this case, the problem with the blood vessels going back up to the heart is not the same as what we described in the first part of the talk with the blood vessels in the muscles. So in the muscles, the blood vessels are not opening, but with the blood vessels going back up to the heart in ME/CFS, the blood vessels are not tightening. They're staying too open, usually. So please bear that in mind. I'll say why later. It's very important to understand that in one part of the body, one problem is happening, and in another, it's different. Okay, so those are the reasons for the hypoperfusion, the main ones. We're now going to move on to part 2 of the talk, which are the cellular disturbances, also very important. So for a long time, I'm sure you've all heard of this. People talk about at a cellular level in ME, the energy production of the cells is going low. It's slowing down. People talk about mitochondrial issues, the things that power the energy creation. It's dysfunctional. And this is interesting because a lot of ME patients actually eat a healthy diet, trying to improve their health, but they still have a really poor energetic state at a cellular level. And we've got trillions of cells throughout our body, but they're slowing down. And so the question is like, why is this actually happening? And this research can offer a pretty good explanation for why it's happening. And it's happening for a few reasons. So the first is everything we've just described. So if you have a situation where the body is not perfusing with blood and oxygen normally, the cells are going to respond to that because they need the blood and oxygen to function. It's required. So if the whole body is not getting that, the cells are going to start slowing down as well. Other reasons for the dysfunction include the dysautonomia, things like lower cortisol, lower thyroid hormone. But everything we've just described is making the cells unhappy and they start to slow down. But what's the main problem at a cellular level in ME/CFS? So this was new to me. I imagine it may be new to a lot of you as well. It concerns something called the sodium-potassium pump, the cellular sodium-potassium pump. Now, as I say, we have trillions of cells in our body. They are integral. They're integral units. They're protected by membranes. And for a cell to be happy and to function well, it depends on having a certain amount of sodium and potassium inside it. It needs a certain balance. And it needs there to be more potassium than sodium inside of it in order for it to function well. Now, how does it actually achieve this? It's this pump, the sodium-potassium pump. So it actually sits on the cell wall, this pump, and it pumps sodium and potassium in and out of the cell. And it normally takes out 3 sodium ions for every 2 potassium ions. So it's taking out more sodium than potassium. And in order to maintain the health of the cell. This pump activity is so important for the health of the body that at rest, it takes up to 40% of your body's energy just to maintain this pump. It's absolutely essential to all bodily processes and the functioning of the body. So what if something goes wrong with it? Well, you're really going to feel it. And so this is what happens in ME/CFS. Sodium-potassium pump dysfunction. So in a context where the body is experiencing this lack of blood perfusion, this low energetic state, sodium-potassium pump also starts to slow down because it responds to that. This means it's not able to keep up with its normal requirements to maintain sodium and potassium normally. Now, this is what happens. This is the important thing to take away. This means that the cells begin to have too much sodium inside them and not enough potassium. And this was proven in a study by these two researchers. They actually measured the cells of ME/CFS patients, and they found that they had too much sodium inside them in comparison with healthy people's cells. Now, when you have this situation, the cell becomes very unhappy and is not able to work properly. So the medical term or the technical term for this is high intracellular sodium. What does this result in? Well, nothing in the body can work optimally in a situation like this because everything in our body depends on the functions of cells. But it will result in major muscle weakness. And a really easy fatigability of the muscles. It is absolutely key as part of crashes and post-exertional malaise, this high intracellular sodium. It's a key part of being stapled to the couch, is that this will be going up and your muscles will be becoming extremely weak. But ultimately, it will make everything worse. So that's then the cellular level of ME/CFS. We're essentially almost finished part 2 of the talk as well. I just want to give you a reminder. Everything that I've talked about gets worse during a crash. It'll all ramp up this activity. And we can talk about that more, but I think there are even ways, once I've learned about this research, when you actually listen to your body during a crash, I think you can feel some of these things actually happening. Okay, so now let's come to the summary. If you've been finding that difficult to follow, if it's been hard, I'm going to go through everything again with this diagram. I've got lots of arrows, I've got lots of numbers, so I'll speak it through, and hopefully if it's been hard to follow, this will be clearer. So in the center of this diagram, we have this general state of global hypoperfusion, lack of blood perfusion, lack of blood seeping into many different parts of the body, particularly muscles and brain, leading to exercise intolerance, post-exertional malaise, cognitive dysfunction. Okay, if we go up to the top left of the diagram, we have the autonomic dysregulation, the excessive flight or fight, sympathetic situation in the nervous system, stress response, light, noise sensitivity, etc., as well as the autoimmune problems that end up affecting the blood vessels. That leads over in an arrow to point number 2 in the top center, which is the vasodilation impairment, not allowing the blood vessels to open up to get the blood into the muscles, brain, and organs. That will then be the first main contributing reason straight down to the global hypoperfusion. Then, if we go to the top right, the brain doesn't like this situation, it hates this situation, it wants to try and fix it. And so it goes to that system I told you about, the Kallikrein-Kinnan system, to create some vasodilators. Doesn't work. Instead, as a byproduct, it causes salt loss, lowering the blood volume, and it causes the vascular microleaks, which also causes the lowering of blood volume because the blood seeps out of the blood vessels. And then that problem will also feed into the global hypoperfusion, making everything worse. Then in the middle top left, we have those microclots, which are being created from the the autonomic dysfunction and the general inflammatory state of the body. So the clotting pathways become upregulated, leading to the microclots, thickening the blood, impairing the transfer of oxygen into the muscles, and then further worsening the hypoperfusion. And then we have in the bottom right, an arrow going down to this heart preload failure. So the global hypoperfusion, for all these reasons, and many others I haven't described today, but they're less essential, leads down into a situation where the heart isn't able to pump out blood adequately, which then feeds back up into the hypoperfusion, because if you can't pump out blood properly, you're not perfusing the tissues with blood adequately either. So all these factors are combining. Finally, the hypoperfusion goes down almost finally into the sodium-potassium pump dysfunction, the development of this excessive amount of sodium inside the cell, which makes the cell unhappy, unable to work normally, and to major muscle weakness, leg heaviness, etc. And I just wanted to point out one other arrow here, which is really important. From the left to the global hypoperfusion, it goes back, as you'll see, up into the autonomic dysregulation. This illness is itself extremely stressful for the body. And all of these things, when they are in place, are freaking out the brain and making it very stressed. So it's all a cycle. It's all a cycle. So ultimately, everything's feeding back into each other. And at first, all of these things seem complicated and puzzling in and of themselves. But one thing is leading to another, and going back to the beginning. So actually, it's all one cycle ultimately, according to this model, which I personally find convincing. Certainly, I feel like it explains what it feels like to be in my body, particularly when I'm in a crash. So that is the summary of the research. I also wanted to say is, I think this also shows why chronic fatigue syndrome is a very poor name. I personally like ME as a name, but the idea that this is chronic fatigue, of course one is exhausted at times and all that, but listen to all this, lack of blood perfusion throughout the body for all these reasons. Chronic fatigue syndrome is a really terrible name, in my view. I know that one of the people who came up with it now really regrets it, but unfortunately it's kind of there, and I think it really doesn't help. Anyway, I've one very profound conclusion to make from all of this, which I'm sure you'll agree with. No wonder it feels so shit. Okay. So I'm sure that's clear enough. But let's try and be more optimistic. So let's move on to part 3. Treatment options that may be based on these ideas. And there might be a lot of treatment options based on this. And I know I've seen a YouTube interview with Professor Scheibenbogen, one of these researchers, and she talked about various things. And I'm sure lots of things could come. But I'm not at the same time, I think some systems may catch on a little bit sooner than others to this kind of research and other similar great explanations for the illness. But in general, places are slow, and I'm not massively hopeful that systems are going to cop on and really help people too soon. But I do think that understanding this kind of research can help the informed ME/CFS patient make better decisions for themselves, and also to actually understand what they're dealing with. So I think that the key really is to think about what are the main burdens in this illness. Because there are, on the basis of this research, there's about 6 main burdens. And I think one of the reasons it's so hard to recover from ME/CFS, because these burdens weigh down the body so much, and it's really hard for it to decide, well, actually, the situation is okay now, I'm just going to get well, as you would from potentially other health problems. Not always, obviously, but I think there's too many burdens. Those burdens are the autonomic dysfunction, the autoimmunity, again, a huge topic, only touched on very briefly today, sodium-potassium pump dysregulation, the low blood volume, the microclotting, the vasodilation impairment. So ideally, you'd want treatments for each of those to really reset that burden, take the load off the body, give it an easier time, maybe it will decide to recover. Now, in capital letters here, why I was talking about this earlier. Remember, the blood vessels going back up to the heart are not constricting normally, in contrast to the vasodilation problem everywhere else. Klaus Wirth, in a talk, made very clear, do not take a vasodilator based on this research. Because yes, you will make the situation in the muscles better, but you will make the situation with the blood vessel return to the heart worse. So he says there is no drug at the moment that can simultaneously vasodilate in one place and constrict in another in a way that would be needed in ME/CFS. So that's, according to him, there's not an option for that problem at the moment. But the other 5 problems we can talk about. So in an ideal world, an ideal health service would offer or suggest the following. So with a low blood volume, I talked about last time the drinking of oral rehydration solutions. I personally find this extremely effective. It's been the most helpful supplement I've ever taken, and it's a real keeper for me. In Ireland, that's diorolite. There's also medications like Fluorinef, which hold on to salt in the body, and some ME patients find that very helpful. So that kind of thing can really take the burden off. Then there's the microclotting, how to actually reset that. Some long COVID researchers have created this therapy called triple anticoagulant therapy. It's 3 anticoagulant drugs that you take at the same time. You take them for 3 or 4 months, obviously under supervision of someone who knows what they're doing, because anticoagulant drugs can be very dangerous. And what they have seen, including in published research, is that this typically actually resets the microclotting situation back to normal after 3 or 4 months, and then you don't need to take the drugs anymore. There's also the blood washing procedure that I did in Germany, which is available in Germany, Cyprus as well, called hypoperfusion, which actually washes the clots out of the blood. So this, I think, in a health service that really cared would be offered to ME/CFS patients if they had this problem. You have the microclots, let's give you 5 sessions of this, let's reset this problem and make your quality of life better, increase your chances of recovery. The next big burden is the autoimmunity. It varies from person to person, this problem, but it can be huge as an issue. It can be a real stumbling block and can create a lot of symptoms. Now, at the moment, again, this is only in Germany, there is a blood washing procedure in dialysis centers called immunoabsorption. It's very expensive, but it has been studied for ME/CFS. And in some people, it has great results. They actually recover from this by using this treatment. Other people, somewhat better. Some people better, then go back. Other people get worse because of the nature of the treatment. They maybe find it too taxing. But that's something that has been used. In 2 or 3 years' time, there will be a new treatment available, which is likely going to be much less expensive. It's called Berlin Cures 007. It's going through trials for long COVID at the moment. It would also be available off-label for ME/CFS in a few years. It is an infusion that neutralizes the autoimmune problems in ME/CFS. There might also be future medications. I know some researchers are working on that. I also wanted to say that you can test for these autoimmune problems using a lab in Germany, which you can FedEx bloods to. I have the website there. It's cellfriend.de. They're not available elsewhere, I believe, to be tested for at this time. I myself tested positive for all of these autoimmune markers when I was in Germany, but I didn't do anything about it. Then there's the autonomic dysregulation. Now, again, this is being fed into by the nature of the illness itself. This flight or fight response, its body is freaking out because of the nature of how stressful it is to be in a body like this. But I do think that ME/CFS patients, certainly I know from myself and plenty of people I've seen, do often find things like meditation and visualization helpful to softening the stress response and improving quality of life. So I think things like that are actually very helpful. I practice them myself. I find it can actually decrease some symptoms like light sensitivity, noise sensitivity, and being excessively stressed about things. And then finally, what about this sodium-potassium pump dysfunction that we were describing, the high sodium that develops in the cell that's crucial for post-exertional malaise? Could there actually be a drug for that one day that could correct that? And indeed, there might be one day. So this is the last slide. Klaus Wirth, the second of these researchers, he gave me permission to share this with you today. And he's founded a company called Mitodicure. And this would actually be the world's first ME/CFS targeted drug. He's identified a compound that could actually correct the sodium-potassium pump dysregulation. And the reason this is so key, not just because you'd feel a lot better, but if you can correct that dysfunction, according to what Klaus Wirth says, you're not really going to experience post-exertional malaise. So you wouldn't actually be able to experience a crash in the way that you currently do. And this would be really important because if you're not going to crash thanks to a pill, it's a simple tablet, simple enzyme, you're going to break such a vicious cycle in the illness because crashing really always ramps up all these problems and embeds them. So he showed in one little internal study in his company that when you impaired the muscles of rats with high intracellular sodium and they became very weak, this compound increased their muscle force from 14% to 64%. So it has real potential, this, as a drug for ME/CFS. Now, I'm saying this last point, actually, in all seriousness, not just in jest, but if you do happen to know of any politician or very wealthy person with ME/CFS or has family with ME/CFS who actually might be interested in funding what would be a phase 2 trial for this drug to bring it to market as an ME/CFS treatment, do mention it to me because I could pass it on to Klaus Wirth. And he is actively looking for funding, a government body or someone who's interested in investment like this to actually test this drug out and get it out there for ME/CFS patients. So fingers crossed for that. I certainly have a lot of hope for that drug in the future.